Hello, everyone, and welcome to Chapter 6B, Measures of Variation. So, variance helps us understand how closely our data varies around the mean. The simplest way to describe the variation of the data is to compute its range. The range of a data set is the difference between the highest and lowest values. Okay? There are some other ways we can describe the data. Specifically, lower quartile, middle quartile, and upper quartile. The lower quartile is the median of the lower half of the data. The middle quartile is a very fancy way to say the median. And the upper quartile is going to be the median of the upper half of the data. Okay. So lower quartile, the median of the lower half, middle quartile, just the median, upper quartile, median of the upper half. All right. And then we can use these to make the 5-number summary. The 5-number summary is called the 5-number summary because there are 5 numbers to summarize our data set. Fabulous, right? So 5-number summary consists of it is going to be the lowest value, the lower quartile, the median, the upper quartile, and the highest value. Okay, 5 numbers. Lowest, lower quartile, median, upper quartile, highest. Okay? So let's go ahead and practice finding these things. Boop, boop, boop. We're going to compute the range, lower quartile, middle quartile, and upper quartile of our data set. Our data set, unfortunately, is not in order. So the first thing that we need to do in order to be able to find the median, lower quartile, upper quartile, is we do need to put it in order first. So I always look for the smallest number to get it started with. So we are going to start with 69. All right, now that we've got all these numbers in order, we can start by trying to find the median. Okay, so let's see here. So 82 is going to be our median. Median. All right, next we need to find the lower quartile and the upper quartile. The lower quartile is the median of the lower half of the data set. So we'll look here, and it looks like we have, let's cross out the lines, 72. So here's our lower quartile. All right, and now we find the median of the upper half. All right, looks like we've got 90. Okay, so once you have found the median, you just divide your data set into these two halves, and you find the lower quartile and the upper quartile. You find the median of the bottom half, the median of the top half. Now to list out our lower quartile, median quartile, upper quartile. Lower quartile 72. Median is 82. Upper quartile is 90. And then the other thing we are asked to find in this problem was the range. And remember that the range is just the highest value minus the lowest value. So that means our range is 96 minus 69. Which is 27. Cool. All right. Now we're going to use our lower quartile, median, upper quartile, highest and lowest values, our 5-number summary, if you will, to construct a box plot. A box plot shows the 5-number summary visually with a rectangular box enclosing the lower upper quartiles, a line marking the median, and they call them whiskers. I like to call them lines. Lines that extend to the low and high values. Steps in drawing a box plot. We are going to draw the number line. We're going to enclose the values. We're going to draw a vertical line at the median, and then we're going to draw horizontal lines connecting the lowest and highest. So let's go through it step by step with an example. Consider the following two data sets of 20 100-meter running times. Compute the variation of the two data sets with the 5-number summaries and their box plots. So let's go ahead and start with set 1. Okay, so our lowest number is the 9.92. So the lowest is 9.92. And the highest is 10.38. Okay. So now we need to find, generally my strategy is do lowest, highest, and then I find the median next. So let's go ahead and try to find the median. So we'll start knocking these out. So our median is 10.13. Next, we need to find the lower quartile. So we're splitting our data set at the median. We're looking this way for the lower quartile and this way for the upper quartile. All right. So lower quartile. And upper quartile. And now this is a 5-number summary. What I have over here under set 1, this is the 5-number summary of set 1. Let's move on to set 2. All right, again, we will do low, lower quartile, median, upper quartile, and the highest value. So starting with the lowest, it's 9.89. The highest is 12.00. Next, I will find the median. So we have two numbers. So the median is actually going to be, so we have two numbers, which means the median is actually going to be right here in the middle of those two numbers. So what we need to do is, to find the median, we will do 10.98 plus 11.05 divided by 2. So we'll get 11.015. Next, we will find the upper and lower quartiles. All right, let's start with the lower quartiles. So again, the lower quartile is going to be in between two numbers. So that means, so this is for the median. So for the lower quartile, we'll have 10.35 plus 10.41 over 2. So we get 10.38. Now for the upper quartile, again, two numbers. So upper quartile is the middle of these two numbers. So upper quartile, we will have 11.55 plus 11.76 over 2. So we get 11.655. All right, now we have our 5-number summaries for both of our sets. What we're going to do next is draw the box plot. So I'm going to scroll back up to the instructions. We want to draw first a number line that spans all the values in the data set. I will do that first. So it looks like we need to encompass both of our data sets. So the lowest number between both of the data sets is 9.89, and then the highest is 12. So let me draw here. Okay, so what we're going to do first in drawing the box plot is draw a big L. And then what you're going to do is label all of the most important numbers. So I usually like to start at the smallest number. If we just kind of scroll up, we see that the smallest number is going to be this 9.89. And then our highest number is going to be 12. And then you just kind of label all the numbers in between that in order. Okay, and as y'all can see, I kind of left a big gap between 10.38 and 10.01 or 11.015 because that is a bigger numerical jump than the rest of our numbers have been. So like 9.92 and 10.06 are pretty close together, but 10.38 and 11.015 aren't that close together. So I just kind of spread them apart a little more. Then we'll label set 1, set 2 over here on the sides. All right, and if y'all remember, set 1 was purple. So you see all of the numbers that we had labeled, the lower quartile, the median, the upper quartile, and the high are all going to get tick marks. So 9.92, 10.06, 10.13, 10.21, and 10.38, because those are the 5 numbers. So those all get vertical lines. The next step is to just draw a horizontal line through it. The last step is to make these middle 3 a box. And there you have it. There is your box plot. The second set we were doing in green. And if we go look up here at the second set, it actually starts at 9.89, which is our lowest number. So it's going to start here with its first tick mark. I know that the highest tick mark is at 12. And then we also have 10.38, 11.015, and 11.665, which are here, here, and here. So then what the goal is to be able to draw a line, straight line that crosses through everything. And we were close, we were very close. Straightish line, that's what we're going for today. Then the last step is to make a box around your lower quartile, your median, and your upper quartile. So as you can see, all we did was put vertical tick marks at every single number, connect them all with a horizontal line, and then your box encloses your lower quartile, your median, and your upper quartile, which we got from the 5-number summary that we did first. All right, so this is your box plot. Moving on to standard deviation. Standard deviation is the single number most commonly used to describe variation. Standard deviation is a measure of how far data values are spread out around the mean of the data set. So these steps in computing standard deviation, it's very important that we follow them exactly. So step number 1 says we are going to compute the mean. So we have 2 plus 8 plus 9 plus 12 plus 19 divided by 5. So you should get 10. Okay, that was step 1. We are going to now find the deviation from the mean. That is data value minus mean. Okay? So to find the deviation from the mean, all we're doing is data value minus mean. So we'll have 2 minus 10, 8 minus 10, 9 minus 10, 12 minus 10, and 19 minus 10. We are doing data value minus mean. Okay, 2 minus 10 is negative 8. 8 minus 10 is negative 2. 9 minus 10 is negative 1. 12 minus 10 is 2, and 19 minus 10 is 9. All right. The next step says find the squares of all the deviations from the mean. So what we are going to do next is square all of these. So -8 squared is 64. -2 squared is 4. -1 squared is 1. 2 squared is 4. 9 squared is 81. Okay. Now that we have squared all of the numbers, we can look at the next step. The next step says add. Add all the squares. So step 3 is to add these boys. Okay. I got 154. All right. The standard deviation is the square root of this quotient. So this right here, this sum of the deviations from the mean squared, is this number here. That's what we found. Okay? That's what that is. So lastly, let me write down this formula. So we are going to do, so standard deviation is equal to the square root of the sum of the deviations from the mean squared divided by total number of values minus 1. So that means we have standard deviation is equal to the square root of 154 divided by 5 minus 1. Which is the square root of 38.5. So that means that the standard deviation is equal to 6.205. Okay. So as one single problem, first we find the mean. Second, we do data value minus mean for every single one of our data values in our set. Third, we square those values. Fourth, we add them all together. And lastly, we use the formula. All right. Let's do another example of the same problem. All right, so the first thing that we are going to do is find the mean. So I got 57.57. All right. So next, let's go ahead and start to subtract. So the next step is to do data value minus mean. So I'll go ahead and list out all of our data values. We have 29 minus 57.57. We have 66. All right. So I have listed out all of our data values. The next step is to do the subtraction. So everyone go ahead and do your subtraction. All right, so next what we're going to do is square each of these numbers. And then the next step is to add all of the squares. So we're going to add going down. All right, and then the final step is going to be to use the formula. So the formula is standard deviation is equal to the square root of the sum of the deviations from the mean squared divided by total number of values minus 1. So remember that this number we find here, this is the sum of deviations from mean squared. That's that number. So that means we get 2867.68 divided by the total number of data values of our set is 7. 1, 2, 3, 4, 5, 6, 7. So I have 7 minus 1. So that's going to be 2867.68 over 6, which is going to be the square root of 477.95, which is 21.86. All right. So to recap one more time, we find the mean. Once we have found the mean, we subtract data value minus mean for every single data value in our set. And then once we have those, we square them, which is the green part. So you square every single one of those numbers individually first. Once they are squared, you then may add down. And once you've added, that is the number that goes in the numerator of your fraction. We divide by total number of data values minus 1, and then we take the square root. And that is how you find the standard deviation. All right, this concludes the notes for chapter 6B. Thank y'all for watching this video, and I hope that you enjoy the rest of your day. Bye.